This group box controls the detection process once scans have been imported into Scantra. The detection process is the first step of the three-stage station adjustment in Scantra, followed by feature matching, and finally, a block adjustment. 3 checkboxes are used to control which features should be detected within scans, namely planes, spheres, and checkerboards. The process can be either started in the detection group box under the Start tab by clicking the detective icon, or in the Station Context menu. A requirement for this process is that the associated point clouds can be accessed. Right after import, the station markers have a red outline, which highlights that the detection process has not been carried out. After successful detection, the respective station receives a black outline, while a circular segment depicts which features were detected. If no scans are selected in the graphics window, Scantra will perform the detection process for all unprocessed scans that are active in the project tree. Given the case that other features should be detected after a first detection phase, the user needs to explicitly select the stations in the graphics window. This behavior has been implemented as a safety measure in order to avoid long run times. Should a user has selected particular scans of interest, the detection process will be carried out only for these scans. The detection phase is limited to 4 threads to prevent RAM shortages. After initiation, the corresponding point clouds are loaded into the RAM and are immediately erased after the detection process is completed for a scan. This yields in a low RAM consumption, regardless of how many scans are about to being processed. The corresponding settings can be found in the Detection tab of the Settings dialog and are discussed in the following, among other specifics. The results of plane detection are adjusted plane parameters with complete covariance matrices that are stored in the project database and serve as a stochastic model in the following adjustments. The plane detection process runs fully automatically in the background and takes approximately 20 to 30 seconds per station. By selecting the menu item Show Bitmap in the Station Context menu, a processed image of the scan is displayed in which the detected planes are colored, depending on the selected display mode. The plane detection process can be controlled with the following parameters. Maximum number of planes per station limits the number of planes per station. The distribution of the planes in 3D space is taken into account. Threshold for planarity. Maximum noise of the points on the surface of the plane. Minimum number of points that must be on a plane. It is recommended to work with the default parameters. In order to detect spheres, their diameters must be set in the Options dialog. After the process is completed, local points are created in the coordinate system of the respective station. The respective centers of detected spheres are highlighted by a cross and an identifier. Per default, the marker will be tinted in red, indicating that the point has not been matched yet. After matching, the marker will be displayed either in cyan or blue. Colors can be customized under Settings in the color ribbon. Every spherical target will receive an individual covariance matrix which serves as a stochastic model in the following adjustments. The sphere detection process can be controlled with the following parameters. Use station name as prefix. When this option is selected, the station name precedes the point ID as a prefix. Sphere diameter 1 to 3. Up to 3 different diameters can be specified for the spheres to be detected. If there is a 0 in the field, it is ignored. Minimum number of points per sphere, maximum sigma 0. This option specifies the maximum noise of points on the surface of the sphere. Maximum sigma p defines a maximum value for a point's standard deviation regarding the adjusted spherical center. Prefix point number. When creating new points, the point IDs are incremented within a station starting from 1. it is recommended to extend the point number with a prefix, for instance, _S for sphere, to distinguish spheres from checkerboards. Note that certain diameters can be left out of the detection process for certain groups. Therefore, navigate to the project tree and select Group Properties, rename Group from the context menu, and untick the unwanted diameters for this group. This function saves runtime if different sphere diameters are used under varying project conditions. For instance, 14.5 cm spheres for interior use and 20 cm spheres for outdoor use. Before the detection can be started, the used target patterns and target diameters must be defined. This can be achieved in the settings under Detection. After completion of the checkerboard detection, local points are created in the coordinate system of the respective station. The respective centers of detected checkerboards are highlighted by a cross and an identifier. Per default, the marker will be tinted in red, indicating that the point has not been matched yet. After matching, the marker will be displayed either in cyan or blue. Colors can be customized under Settings in the color ribbon. Every checkerboard target will receive an individual covariance matrix which serves as a stochastic model in the following adjustments. The checkerboard detection process can be controlled with the following parameters. Minimum diameter of the target used. For a square target, it means the side length, not the diagonal. Pattern of the target used. The user must specify which target patterns were used in a project. Maximum sigma p defines a maximum value for a point's standard deviation regarding the detected target center. Prefix point number. A point is generated after successful checkerboard detection. The point IDs are incremented within the station, starting from 1. Analogous to spheres, it is advisable to set a prefix for the point number, for example, _C_, to distinguish detected checkerboards from other points.